Okay, we are solving this paper 1 for AS today. This is February March paper 2016, paper 1, 2, an MCQ paper obviously, and let's start with the first one. Now, the prefixes nano, micro, and pico are often used in units, and we know that they are very commonly used. Which row shows their correct values? And only way to do that is first write down what are the values for nano, micro, and pico. Nano is 10 to the power minus 9. Pico is 10 to the power minus 6. And sorry, micro is 10 to the power minus 6, and pico is 10 to the power minus 12. Which row is saying everyone is correct? Over here, this is correct, incorrect, 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 correct, correct, correct. So C will be the answer in this one. All three must be correct for option to be correct. So this is the second question is from vectors. We need to find components of forces over here. A crane has an arm which is attached to a frictionless pulley. The cable passes over the pulley and 10 kilometers as shown. The crane arm exerts a force of F on the pulley. What is the value of F? Now we know when everything is in equilibrium, it means the total force exerted this way is balanced by the force F. So this force is actually the combination of two forces. One is 10K cos 30. The other one is 10K cos 30 as well. So total force will be 2 times 10,000 cos 30. Answers are in kilonewton, so we do not need to convert them into 1000. Let's make it 10. So it will be 20 cos 30. Using a calculator, 30 cos, oops, 30 cos. Why am I dividing with 0.02? Clear, clear, clear everything. So 30 cos multiplied by 20. 17.32. So that shows that answer should be D. This is the closest. Now, third question is about quantity algebra. We have a specific capacity, which is in joules per kilogram per Kelvin. And examiner wants us to express the same unit in SI base unit. So SI base unit means that we cannot use newtons or joules or watts. We have to use kgs and meters and seconds. So in this unit, only joule is making problems. So joule is actually kg meter square per second square multiplied by kg multiplied by Kelvin minus 1, kg minus 1. So we see that kg plus 1 and kg minus 1 will simply be cancelled with one another, and rest will be exactly as it is. And we have same unit over here. So answer for C, third question will be C. Quantity X has a fractional uncertainty and quantity Y has a fractional uncertainty small y. What is the fractional uncertainty of X over Y square? And what do we know about this thing? fractional error of product of formula. Product means the subject of formula. Fractional error of the product equals to sum of fractional errors of factors. Now, what are the factors in this case? We see there is an x and there are two y's. So it should be fractional error of x plus fractional error of y plus fractional error of y. Or some people do it x plus 2y, which will be the answer in this case. This will be the fractional error for the quantity that has been calculated by x divided by y square. Now, question number 5 is P, Q, R, and X, Y, Z are Y's in a circuit. A galvanometer connects Q and Y as a null indicator. So the reading on the voltmeter must be 0. When the galvanometer reads 0, which statement is correct? If galvanometer, which is actually a very sensitive voltmeter, is reading 0, it means that the potential difference across the voltmeter is 0. The electric potential at both points is exactly same. So which option says that the potential difference between Q and is infinite? Then voltmeter reading should be maximum. The resistance between Q and Y is infinite. No, it doesn't make any difference. Voltmeter is supposed to have an infinite resistance. That makes no difference. The resistance between Q and Y is 0. So answer will be B. The potential difference between Q and Y is 0. That can only be true for this situation. So null indicator means let me explain this thing. We keep on changing the resistance on P and R and Z. And listen, this is a part of a big circuit. It is not the complete circuit. So we can make changes on X and Z and R and P, and those changes are changing the reading on the voltmeter, and we wait for the reading to become 0. This is what is meant by null indicator, that the voltmeter is reading 0. Okay. Question number 6. An object has an initial velocity u and an acceleration a. The object moves in a straight line through a displacement s and has final velocity v. The above equations are related by this and this and this, which are the conditions. So he's asking for the condition. Now, condition for applying equation of motion is these equations of motion, all of them, are only applied if acceleration is constant. And remember, acceleration constant means direction of acceleration is also constant. Some only think of acceleration as a magnitude, but as acceleration is a vector quantity, it is affected by direction as well. So which option is correct for this one? The direction of A is constant and direction of A is the direction of A is constant and direction of A is same as the direction of S. It is not necessary. The direction of A is constant and direction of A is the same as direction of U. That is not necessary as well. The magnitude of A is constant and direction of A is constant. So that is the answer for this one. Just to be sure, let's see what is wrong with option D. The magnitude of A is constant, direction of A is same as well. No. Direction of acceleration and the direction of velocity are not connected with one another. So it is not necessary for acceleration to have any direction along or against any velocity. The acceleration can have any independent direction. Now, moving on to question number 7, a car is traveling at a constant velocity. Remember, the velocity is constant, the brakes are then applied, causing uniform acceleration. Which graph shows the variation of distance s and velocity v? The object is traveling with decreasing speed. Okay. Now we have to look for constant speed in the initial part, and examiner has done that. He has made all of them with constant speed in the first part. So all of them can be right for that. Now object speed will be decreasing and distance will be increasing. That is one thing for sure. Object will still be going forward, slowing down, but still going forward. So it is supposed to travel more distance in the initial part and less distance in the last parts. So obviously, object is not having a constant relationship between them. So D and B can be cancelled out. So this C is showing that there is a lesser distance travel in the initial part and more distance travel in the same amount of time in the last part. It means object is slow here and fast here. Look over here. Object has traveled more distance in the initial part and less distance in the last part in the same amount of time. So object is fast here and slow here. So this makes more sense. Object is travel. If we make same gap, look, same gap. So this distance is traveled with more speed, and this distance traveled with less speed. So this is how the graph should go down. This graph is showing that the object is slow here and fast here, which is not the case. It is fast here and slow here. So graph should be like. Now, a ball is thrown across a flat field. This is a projectile question. Which statement describes the motion of the ball when effect of a resistance are ignored? So remember, when object goes a projectile like that, it is having two kinds of motion at every time. It is traveling with a constant speed across, and its vertical speed will be increasing and decreasing depending on whether it is going up or coming down. It will be having an increase of speed while coming down and decrease of vertical speed when it is going up. But if a resistance is ignored, this upward and downward acceleration will be same, and across the board or across the screen right now, object will be traveling with constant speed. The ball lands with the same velocity at which it is thrown. So that is a very possible option. But move on. The horizontal component of acceleration is constant throughout the motion, and it is also zero. So that is also a very correct statement. The horizontal and vertical component of acceleration are both zero. No, horizontal acceleration is zero, vertical acceleration is not zero. The horizontal and vertical component of velocity are both zero at the height. No, only vertical at maximum height, vertical component becomes zero, not the horizontal component. So horizontal component will still be the same as it was in the beginning. Now look, first part, A. The ball lands with the same velocity. If it would be speed, then this would be the right answer. So A is not the right answer. Because you can see initially the object's velocity is this way. And when it is landing down, the velocity is this way. So how can two different velocities in two different directions can be equal? Remember, Velocity is a vector quantity and we have to pay respect to its direction. Okay? Magnitude might be same, but the direction of velocity is not same. We cannot say the velocity is same. The horizontal component of acceleration is constant throughout. Yes, it is constant and it is zero as well. So B should be the answer for this. Now, which statement defines force? Before we read these options, what do we know about force? What should come to your head when somebody says force? Force is a push or pull. Force can accelerate something. Force can turn something. Force can bend something. Force can stretch, compress. So these are the things force can do. Force can deform something, in the short word. It can change the kinetic state of an object. But force cannot do is force cannot change the mass of an object if it is a single object and its content is fixed. Mass cannot be changed by force. How do we define force? What is the basic formula for force? Force is the product of mass and acceleration. Okay. Or Newton's second law. How many of you remember Newton's second law? Newton's second law is force is directly proportional to rate of change of momentum. Okay. So let's read the options. When a force acts on a body that is free to move, the force is the product of mass and body acceleration. So that is a very tempting option because it is directly connected to F equals to ma. But I will shortlist this one. I cannot completely discard this thing, but let's see what else we have. When a force acts on a body that is free to move, the force is the rate of change of momentum of the body. That is exactly Newton's second law. Let's see what C part says. When a force acts on a body that is free to move, force is the work done by the force divided by distance moved. That is a very good formula to calculate force, but not a definition. When a force acts on a lever, causes a movement, force is D is also a property of force, but still not what defines force. So A and B. Actually, excuse me. Actually, there's no difference between A and B. A says F equals to MA. And we know A is V minus U, so we can make it MV minus MU over T, which is rate of change of momentum. But rate of change of momentum is more basic definition of force. So it is B. So question number 9 done. Moving to question number 10 is from two-dimensional momenta. A particle of mass m traveling with speed u collides with a stationary particle of mass capital M. The velocities of the two particles before and after collision are shown. Now, okay, what is the velocity of capital M? Stationary particle. So it is a stationary particle. Now, it is at rest. So total momentum before collision will be mu. Now, what is momentum after collision for capital M? It is mu by 3. It is mu by 2. What is total momentum after collision? That will be mu by 3 plus mu by 2, and it should be equal to the resultant, and this resultant should be equal to the initial or total momentum before collision, which is mu. Now look for this kind of diagram. Mu is this way, mu by 2. Okay, he made the whole diagram correct. Only mistake is that he switched alpha and beta. This angle should be beta and this angle should be alpha. So that is the only thing wrong in A. Okay, I can see answer is B, but let's see what is wrong with the other one. So because we are just not knowing the answers of every question, we are spending time to actually understand the topic as well. The direction of mu by 2 is incorrect. The direction of mu by 3 is incorrect as well, because these two directions are supposed to be in the opposite way. This is downward, this is upward. And again, and then units are incorrect as well. Sorry, angles are incorrect as well. Over here, angles are correct, but again, the directions are incorrect. So D, C, and A are incorrect. Answer will be B. Okay. It doesn't matter we make diagram complete triangle in this order or in this order. They both are same. Question number 11. An object falls freely from rest in vacuum. The graph shows the variation with time t of the velocity v of the object. This is the velocity. Which graph same scales represent the object falling in air? Okay. If the object will be falling in air, in the beginning, it should have the same acceleration. So velocity graph should be overlapping with the graph over here. So the new graph should be like this. Then air resistance starts to develop and object cannot achieve the velocity that it should have because air resistance starts to develop. And because of air resistance, acceleration decreases and object travels like that. So which option is that? Nope, not A. Not B as well. Not D as well. So answer should be C. A turning effect question is a diagram shows a uniform beam PQ. The length of the beam is 3 meters and the weight is 50 Newton. The beam is supported in the pivot 1 meter from and P. A load of weight W is hanging and the beam is in equilibrium. What is the weight of the beam? So I don't think we need a calculator for this one because it is just a concept of doubling or halving something. The weight of the ruler will be acting in the middle here, which is 50. And it will be 0.5 meter away from the pivot. So 50 into 0.5 should be equal to W multiplied by 1. I think a simple calculation can tell you W must be half than 50 because the distance of W is double than 50 Newton force distance from the pivot. Now, question number 13. Two forces act of magnitude F act on the act at points V and W on an object V and W. The diagram shows the couple of the object right angle triangle. Which expression gives the couple? Oh, okay. For these kind of questions, in your imagination, what you need to do is extend the forces. And you're doing this in your imagination. Now, if these are two parallel lines, what will be the perpendicular distance between these two lines? Will it be x or will it be y? Give it a thought. Will it be x or will it be y? I think you have figured out it is y. Y is the perpendicular distance. So the turning effect will be, if we consider one of them as a reference force, F into Y, Fy. So answer is B. No. A giant squid of length 20 meter is vertical in seawater. What is the top of the squid at the depth of 8 meter? The density of the seawater is this. What is the difference in pressure between the top and the bottom of the squid? Why do we need this 8 meter for that? This is just a diversion for you. So simply you need a pressure that is, for example, let me make a diagram of this squid. Let's say this is a squid. This is the top, this is the bottom. This height is 20 meter. So it doesn't matter where is the top. We need the pressure at the top and the pressure at the bottom and their difference. And it will be rho GH. Rho is 1050 into 9.8 into height is 20. And using a calculator, I get 1050 times 9.81 times 20. So 206010. So rounding it off to 3 cent figures, answer should be B. The force diagram shows an aircraft accelerating. At the instant shown, the velocity of the aircraft is 40 meters per second, at which rate the kinetic energy is increasing. You know, there are some very basic rules that we can discuss over here. If we multiply applied force to okay, if we multiply applied force and distance, that is total work done. If we do net force multiplied by distance, this is gain of kinetic energy. If we do friction multiplied by distance, that is work done against friction. But for power, we know one of the formulas for power is power equals to force into speed. So if it is applied force multiplied by speed, then it is work done by the source or total work done. Total, okay, so not work done, total power dissipated by the source. If we do net force multiplied by speed, that is rate of change of kinetic energy. Remember, when we were multiplying net force with distance, we were getting gain of kinetic energy. And when we multiply net force with speed, we get rate of change of kinetic energy. Similarly, if we multiply frictional force with speed, we get the rate of work done against friction, or if all of the friction is supposed to be converting into heat, then net force multiplied by frictional force multiplied by V is rate at which the heat is being produced. So, at which rate the kinetic energy is increased? Resistive force is 200, engine thrust is 500. So, what is the difference? 300? 300 multiplied by 40. 300 into 40 equals to 12,000 kilowatt. That is 12 megawatt. 12 megawatt. And answer should be C. Okay, moving on. A man is running in a straight line. What is the approximate value of his kinetic energy? So it is a question of estimation. What is a reasonable estimate of a person's mass? Say 100 kg. Okay. What is the speed of the person? Say 10 meter per second. What will be his kinetic energy? 1 by 2 into 1000 into 10, 5000 joule. The value of kinetic energy. Now, why it is 5000? I think it is more close to C. So answer will be C. It is closest to C, but over 2 into 5. Oh, there will be a square as well. My bad. I'm putting 1000 as mass. Sorry. That is 50 multiplied by 100. And I was getting the same answer. So I was thinking I was doing something wrong. So I'm taking 10 meter per second if it is if somebody is very fast, like an Olympic athlete. But if it is an average person, obviously it will be less than that. So 1000 is very reasonable estimate. The pump of water pumping system used 2 kilowatt of electrical power when raising water. The pumping system lifts 16 kg of water per second through a vertical height of 7 meter. What is the efficiency of the pumping system? Now, what is the power developed by the system? We are providing it with 2 kilowatt. And what does it do with that? 16 kg per second to 7 meter. So that is a gain of kinetic gravitational potential energy. Gain of gravitational potential energy will be 16 into 9.8 into 7, and efficiency will be percentage efficiency. Whatever answer this thing gives you, divided by 2000 multiplied by 100. Okay, let's bring the calculator. 16 multiplied by 9.81 multiplied by 7 divided by 2000. 0.54, and when multiplied with 100, so it is about 55%. So answer will be. Next question. A metal wire is stretched by a load. The force extension graph is shown, which what is represented by the area under the whole graph. So this area, force extension graph, this is actually a kind of energy or work done, because force multiplied by distance is always a work done. Let's see what the change in gravitational potential energy of the wire. No, it is not getting higher or lower. So this is not right. This part of this statement is incorrect. The energy that would be released from the wire if the final load was removed, that would be true unless we do not go beyond elastic limit. Till then, if we remove the load, it would have come back down. So this area would be equal. So work done on stretching something would be same as work done by that stretch thing when released. So this area is not same for something which will come back from here, because that might come to a some permanent extension like this on releasing. So nope, not B. The energy transferred into heat energy of the wire. No, it is not that as well. So answer will be D. The Young modulus of steel wire is twice that of copper. 50 centimeter length of copper wire, diameter this is joint 50 centimeter. Length of steel wire of diameter 1 millimeter, making a combination wire of 1 meter as long. Two wires are connected one after the other. Okay, do we ignore the weight of the wires? The combination wire is stretched by the weight added. Both copper and steel wire obey Hooke's law. What is the ratio of extension in the wire and extension in the wire? Listen, whenever examiner asks you for the extension, first you need to make the formula for extension. Young modulus is 4 FL over pi d square E. So small e, which is extension, is 4 FL over pi d square ratio. On the top we have steel. It will be 4. F is same, so F is the weight of the object. Length is same. I will just put L over pi is pi. Diameter of the steel wire was 1 square. I don't need units over here as well, because I'm just finding a ratio. Into Young's modulus. he said its young modulus is twice that of copper, so I'm putting it 2e. Over 4, same load W, same length L, pi, the diameter is twice, so it is 2 square into E. Now let's see what we can simply cancel out. E goes with E, pi goes with pi, 4WL goes with 4WL. So it is 1 over 2 divided by 1 over 4. 0.5 over 0.25. So it is 2 over 1, 2. It should be B. Next question is here, question 20. With which type of wave can Doppler shift be observed? All waves, all type of waves. That is a basic knowledge-based question. So it is all type of waves. A distant star is receding from the Earth with a speed of this meters per second. It emits a light of frequency this hertz. The speed of the light is this meters per second. The Doppler effect formula can be used like what will be the frequency of this light when detected on Earth? It is receding away, so the formula of the frequency received will be original speed divided by speed plus speed of the moving object into original frequency produced. So speed of light is 3 into 10 to the power 8 divided by 3 into 10 to the power 8 plus 1.4 into 10 to the power 7 multiplied by original frequency that is produced by, that is 4.57 into 10 to the power 14. So it will be 3 into 10 to the power 8 divided by 3.14 into 10 to the power 8 into 4.57 10 to the power 14. Okay, sorry for that part was out of the screen. Now, bringing the calculator, we have 10 to the power 8, 10 to the power 8 we cancel with one another. We have actually 3 divided by 3.14. That should be this, multiplied by 4.57. So it will be 4.4 into 10 to the power of 4 point, let me see, 4.37 into 10 to the power 14. Answer should be B. Okay, next question is again from waves, and it is the graph shows the variation with time of displacement of two separate waves x and y. Displacement is shown. Wave x has frequency f and amplitude a. What is the frequency and amplitude of wave y? This is wave x. Now, amplitude of wave y is obviously double, so it is 2a. So answer can be B or D based on amplitude. Frequency. When A completes, wave X completes one wave, wave Y only completes half of the wave. So frequency of wave Y will be half than the frequency of wave X. That means 1 over 2f and 2a. B should be the answer for this one. Diffraction is a term used to describe one aspect of wave behavior. What does diffraction make possible? The ability of to hear around corner, yes, that is done by the fact. The ability of hearing high frequency, no, it does not change frequency. It is not Doppler effect. It is diffraction. Diffraction does not affect frequency. The ability to hear loud and quiet sound, no. The ability to hear sound through a brick wall, no. So it is ability to hear around the corners. The diagram represents a pattern of stationary wave formed by the superposition of the sound wave from the loudspeaker and the reflected wave, so and so, the 4 points of the line through the center of the wave. Which statement about these stationary waves is correct? Which statement about these stationary waves? Now, an antinode is formed at the surface of the metal sheet. Metal sheet. Metal sheet is not shown. There is a metal sheet somewhere over here, and there. And remember, if it is being reflected from here, then at the at the point of reflection there should be node. If there is no node, then this reflection cannot happen. An antinode is formed. Nope, that is incorrect. A node should be formed over here. Nope. A node is a quite quarter of wavelength from the adjacent antinode. That makes sense. I'm shortlisting this one. The oscillation of X are in phase with Y. Nope. They are out of phase by 180 degrees. The air particles oscillate perpendicular to the line WZ. No, air particles are moving along the line WZ. So it is incorrect as well. Answer is B. Okay. Listen, this is antinode antone. From one antinode, from one node to one antinode. This is 1 by 4 of a wavelength. Remember, because one wave is complete from one node to adjacent. That is a wavelength. So from node to nearest antinode, it will be quarter of a wavelength. So answer will be B. A musical instrument called bugle is long tube with mouthpiece at one end and other end is open and flared. A musician maintains a stationary sound wave with a node at the mouthpiece and antinode at the other end. The lowest frequency of the sound produced is 92. What is the frequencies of the sound can be produced by the bugle? Okay, so remember, bugle should always produce an antinode over here. So this can be done. I'm making a smaller bugle like this, or in the same length, you can do like this, or you can do like this. They all will be producing stationary wave in the bugle. Now, what is the frequency of this one? 92, and this frequency is 3 times more than that. This is 5 times. Next will be 7 times. So we can have 92, 92 times 3, 92 times 5, 92 times 7. So these are the possible frequencies. And let's see which list is the correct one. So 92 times 3 is 276. That I can see in the C and D. And then 92 multiplied by 5, that is 460. I can see it over here as well. Then it will be 92 times 7, which will be 644. So C is the answer. C should be the answer for this one. Now, monochromatic. Monochromatic means light of single color. Of wavelength, this is incident normally on a diffraction grating. The first order maximum is observed at this angle. The incident light, what is the angle between the first and the second order diffraction maximum? The formula is d sine theta equals to n lambda. Now, we don't know d. Well, there is one way we can do it with ratio method, or we can do it by calculating d first and then using the same formula again, because the first order is given. That means d sine 15.4 equals to n will be 1 because it is first order, and lambda will be 5.3 into 10 to the power minus 7. So getting my calculator out, 5.3 divided by 15.4 equals to 19.19 into 10 to the power minus 7. So it will be 1.99 or 2 into 10 to the power minus 6 meter is D. Now finding sine theta for the second one, it will be 2 into 10 to the power minus 6 into sine theta equals to 2 times 5.3 into 10 to the power minus 7. These are calculations going on. So 10.6 divided by 2, 5.3, and divided by 10, because 10 to the power 6 and 10 to the power minus 7 will be cancelled. Divided by 10, and then sine, it is 32 degrees. 32 degrees. But answer will be 32 minus 15.4, which is 16.6. So in this case, the answer will be C. Okay, because he asked for the angle between the first and the second, not the angle of the second. Now, the diagram shows the electron in the uniform electric field. In which direction will the field accelerate the electron? Electron is a negatively charged particle, so it will always accelerate opposite to the electric field, because the electric field shows the direction of force on a positive charge. Electron is negative charge, so it will be experiencing force in the opposite way. The electric field strength in a certain distance from an isolated alpha particle is this Newton per coulomb. What is the force on an electron when at that distance from the alpha particle? So all we have to do is multiply this electric field strength with charge on a single electron, which is 10 to the 1.6 into 10 to the power minus 19. So if you multiply 3 into 1.6 is 4.8. So I guess this seems like the correct answer. So these kind of questions sometimes save your time in exam because they're simple. Electric field strength multiplied by charge equals to force. Now, two large parallel plates X and Y are placed distance 5 millimeter apart, connected to a terminal of 200-volt DC supply. A small oil drop P carries one excess electron. What is the magnitude of electrostatic force acting on the oil drop in the plate? So first you need to find the electric field strength for this one, and then use that electric field strength to find the force on the single electron. Electric field strength is change of potential divided by distance. So it is 200 divided by 0.005. Now I can add 3 zeros there. It will remove this, so it will become 40,000 volt per meter or newtons per coulomb. Now it is very much same as the previous question. So we will have 1,001.6 into 10 to the power minus 19 coulomb. 6.4 into 10 to the power 1, 2, 3, 4. 15. So answer is A again. Now, an electric conductor has a resistance of this kilo ohm. The potential difference this and volt is applied across the ends. How many electrons pass a point in the conductor in 1 minute? First, we can use these values to find current, and then we can multiply that current with time to find charge, and then divide it with elementary charge, which is charge on electron, to find the number of electrons. So let's do it. 9 volt divided by 5600, that will be current, multiply by 1 minute means 60 seconds, and then we have to divide the whole thing with elementary charge, which is 1.6 into 10 to the power minus 19. So bringing the calculator, it is 9 divided by 600 multiply by 60 divided by 1.6. So it is 0.060 into 10 to the power plus 19. So when I fix this one, it becomes 6.0 into 10 to the power 17 electrons. So answer will be C. Excuse me for this. Now, 31. A fixed resistor 12 ohm is connected to a battery. There is a current of this ampere in the resistor. The current is now doubled. What is the new power dissipated? There is a current this. The current is now doubled. The formula for power is I square R. If resistance is fixed, you double the current. The power should increase 4 times. And what is the power right now? It is 0.2 square into 12. So when it is doubled, it will become 0.4 square into 12. So 0.16 multiplied by 12. 16 into 12 is 192, 1.92 watts. So it will be C. Now, next part is 32. Which measurement are taken in order to calculate the resistivity of a metal of a piece of wire potential difference? So we take in order to calculate resistivity of a metal piece. Resistivity, the formula for resistivity is okay. It is resistance equals to resistivity into L over A. So resistivity will be resistance into area over L, and area is pi d square over 4. So resistivity will be resistance pi d square over 4L. So what do we need to measure? To find resistance, we need voltage and current. We need diameter and we need length. Diameter, length, current, potential difference. B. Okay. Resistance, area, length. Which measurements are taken in order to calculate the resistivity? So resistance, length, radius. We never measure radius. Actually, the measurements are taken. We measure potential difference. We don't measure resistance. We measure potential difference and current and then calculate resistance. We measure diameter because every instrument that we use in lab measures diameter. And then we measure length and perform the experiment. Now, 33. 12-volt battery is charged for 20 minutes by connecting it to the source of electromotive force. The battery is supplied with this joule of energy in this time. How much charge flows through the battery? Now, the formula is potential difference equals to energy divided by charge. So, charge will be energy divided by voltage. How much energy is flowing? This much. And this is the voltage. I was looking for voltage. So let's calculate. 7.2 into 10 to the power 4 divided by 12. This will be 0.6. So it will be 6 into 10 to the power 3 or 6,000. So answer should be D. And he has given you 20 just to uh, confuse you. Actually, not confuse you. What he will get by confusing you. Examiner just want to see how confident you are and do you actually know what you're doing or not. Now, going to 34th question, I guess. Yes, 34th question. Three cells with EMFs V1, V2, V3 have negligible internal resistance. These cells are connected to three resistors with resistances R1, R2, R3 as shown. The current in the circuit is I. Which equation is correct? So V2, V1, V3, they are all adding up because they all are sending current in the same direction. So it is V1 plus V2 plus V3. I think A seems like the correct answer. Yeah. But look at the current. Current is going opposite to the oh. The current is going okay. This current is this way. They are sending current this way. So V2 and V3 are connected opposite. Let's don't do it with in the air. I should write things up. So current is I. So over here the potential difference will be IR1, IR2, IR3. So if you are going this way, this will be minus V2. This will be minus V3. So it is V1 minus V2 minus V3 plus IR1 plus IR2 minus IR1 minus IR2 minus IR3 equal to 0. Now, excuse me, let's rearrange it. It will become V1 minus V2 minus V3 because he has shifted things on the other side. It becomes I into R1 plus R2 plus R3. So answer should be D. Three resistors, each of resistance are connected in network as shown. The total resistance between X and Y is 8 ohms. What are the values of this? So it is product over sum X into 2X over 3X equals to 8. So 2X square equals to 24X. X equals to 12 ohms. Now, in deriving a formula for combined resistance of three different resistors in series, Kirchhoff law are used. Which physics principle is involved in this derivation? In series, Kirchhoff laws are used. Now, Kirchhoff law, the second law of Kirchhoff's second law, is actually based on energy, law of conservation of energy. So the is first law is based on law of conservation of charge. Second law is based on law of conservation of energy. Over here, first law, the current that goes into the resistance comes out of the resistance. So same current goes in and same current comes out, and the current through each resistor in series is same. It means the charge that flows in a particular amount of time stays same. So it is based on law of conservation of charge. So that would be the answer over here, because if it would be about second law, that is based on law of conservation of energy. The battery of a car has an internal resistance of 0.1 ohm, random force 12 volt. When the battery is connected to a starter motor, the potential difference across the battery terminals is this volt. What is the current supplied to the starter motor? Now the formula of is E equals to V plus IR. So let's use this one to find things. It is 12-volt EMF 7 plus I don't know into 0.1. 5 divided by 0.1 equals to I. Then I will be 50 amperes. So answer will be A. A sample of an isotope emits minus beta particle. The emitted minus beta particle have a range of energies. What must also be emitted? With every beta minus particle, which is an electron, emits an anti-neutrino with it. Okay? Anti-neutrons is nothing, anti-neutrino. So C is incorrect. Neutrons are not, neutrinos is not right, anti-neutrino. So 38 should be A as well. The nucleus of magnetism decay into a nucleus of not magnetism, magnesium decays into nucleus of sodium by emitting beta plus particle. The decay represents this. What are the values of P and Q? So equation should be balanced. P should be staying same, 23. And if it is a beta plus particle, 1 plus has to be less than the, it should be 11. So 23 and 11. 23 and 11. C. Okay, coming to the last question. A thorium-234 decays by minus beta emission into a daughter product decayed by further minus beta emission into a granddaughter product. Which letter in the diagram represents the granddaughter product? Now, you just discussed this thing. When beta particle emits, nothing happens to 234. Okay. So nucleon number should stay 234. So answer is either B or C. No, it is 90. And what happens when a beta minus particle comes out? It goes out, the proton number increases by 1. Another beta particle goes out, the proton number increases by 1 again. So the final beta particle, final proton number should be 92. So answer should be B. With this question, we end the paper. I'm tired. So see you people next time. Thank you very much for watching. Allah Hafiz.